All right, so we have a quick lesson today. It's going to be the start of section 121. All of section 121 is going to be on simplifying expression. So today we're specifically going to be doing a review lesson of something you've learned before. We're working on combining like terms when we have a long expression that involves parentheses and different operations. Starting tomorrow, we'll get into distributing across sets of parentheses involving double distributing and different things in there. But today it's just simplifying expressions where we have sets of parentheses that are um, have addition and subtraction in between. Okay, so if we were going to simplify something like this, the first thing we should see is that there's parentheses around these first two terms, but there's nothing in front of it, right? So if there was something written, it would just be a 1 right there. Okay, so this set of parentheses isn't really doing anything, right? Because if you multiplied 1 to both of these, they would stay the same. So let's rewrite this first part with no parentheses in there, since those parentheses aren't really doing anything. So it's 4 plus x plus, and then the same deal over here, right? There's a plus in between. There's no number in front of these parentheses. Really, there's a 1 there. That's not doing anything again. Okay, plus 2 plus x. Well, now this is just a combining like terms problem. Okay, so now we look for our like terms. We have a 3x and an x. So together, 3x plus x is 4x. Then we have a 4. We have a 2 plus 6. That's it, right? You can't combine those different like terms from there. Notice the order that this was written. Okay, if you put 6 plus 4x, it is an equivalent expression, just not in what we call standard form. Okay, so standard form is if we had any terms with an x that had a power and an exponent that it was raised to, the biggest exponent would go first, working down to just an x, working down to just a constant number at the end. Okay, but this would be our final answer, 4x plus 6. Let's do a couple more. Okay, so example 2. So now we have 3 terms in this first set of parentheses, 2 in the second one. Again, the big thing to notice is just a plus in between. Okay, there's no number out in front here. There's no number out in front here. Let's just rewrite this whole expression without those parentheses. Okay, because they weren't doing anything. They weren't changing any of the terms. Now it's just a matter of looking for like terms. Okay, so if we look, this 7x squared, there's no other term in here that has an x squared. Okay, so it's just going to stay as 7x squared in front. There's no like terms. We have a minus x, we have a plus 6x. So negative 1x plus 6x makes plus 5x. And then this plus 15 we combine with plus 12 to make plus 27. So that would be our final answer. Okay. Let's try another one. So example 3, find the difference. Okay, so notice how this one's different. Okay, we have a minus sign in between. So that is going to change. Okay, there's nothing in front of this first set of parentheses, so that's still going to stay the same where we have x to the 5th plus 8 out in front. Okay, then we have a minus. And now remember, when we have a minus and then a set of parentheses, this is the same thing as distributing a negative 1 to both of these. Right, so our sign is going to flip on both the terms on the inside. It's be minus 3x to the 5th minus 5x. Okay. Again, now this turns into a combining like terms problem. Okay, so in terms of our like terms, we have an x to the 5th, the negative 3x to the 5th. So really we have 1x to the 5th minus 3x to the 5th. That makes negative 2x to the 5th. Then we keep looking. Well, we have a negative 5x. There's nothing that pairs with that. So minus 5x. Then lastly, we have a plus 8. That's just hanging out at the end. And this is standard form. Largest exponent on our terms first, working down to just the x, working down to a constant at the end. Okay. Let's apply this topic to something else. Okay, so let's flip to page 38. Okay, page 38. So now it says the perimeter of a polygon is the sum of the lengths of the sides of the polygon. For 7 through 10, find the perimeter of each shape. All lengths are given in centimeters. Okay, so now we can apply what we know about combining like terms in order to answer this geometry question. Okay, so the key idea that we have to remember is that perimeter of a figure is when we add up all the sides. Okay, it's a length, the length of all the sides put together. If we were going to find the perimeter of this triangle, we would do x plus 14 plus x plus 14 plus 2x plus 36. Well, now this is just a big combining like terms problem. X, 2x, those all make 4x. Then we have a 14, 14, and a 36. So all of those together make 64. So 4x plus 64, that's our simplified expression. Now, remember, this is, now that we're in a context problem, it did say that we're measuring this in centimeters. Okay, so if we're going to write our answer, we'd say 4x plus 64 centimeters. Maybe you're thinking, is it squared? No, perimeter, remember, that's just a length. Okay, it's this length going around the outside. Okay, you could stretch that all out and make one really long length if you broke it all down. Okay, so it's not in square units, centimeters. Okay, try another one. So we have these 4 sides here. Okay, if we really didn't want to write everything out, one trick we could do is we see we have 2 of these 3x plus 6's. We could write that as 2 times the parentheses 3x plus 6 plus, we have 2 of these x plus 2's, 2 parentheses x plus 2. And then we're not rewriting out every single term in a really long expression. Now to simplify, we can multiply across these parentheses. 2 times 3x, that's 6x. 2 times 6 plus 12. And then 2 times each of these plus 2x plus 4. Okay. Combine our like terms, 6x and 2x, 8x, plus combine 12, 4, 16. And we want to put units on it. That's 8x plus 16. In this case, they said still in centimeters. Okay. Why don't you guys try doing number 9? All right, so same idea. Should have wrote out 2 parentheses x squared plus 2 plus 2 parentheses 8x minus 1 and multiplied across both. 2x squared plus 4 plus 16x minus 2. Now we have 2x squared is still by itself, plus 16x is still by itself, and then we combine 4 and negative 2 to make 2 centimeters. All right, do this last one, and we'll check and see how we did. All right, so these are all different, so we have to write it out as a big string. So we'd write, sorry, I'm running out of room, x squared minus x plus 6x minus 3 plus x plus 12. And then we combine our like terms. X squared, still by itself, negative x, positive 6x, positive x. The negative x and the x cancel out. We're left with just plus 6x. Then we combine, we're going to combine the negative 3 and the plus 12 to make plus 9. Okay. So that's our lesson today on day one of 121. So we're combining like terms where we have parentheses separated by addition and subtraction.